Hey guys, welcome to lesson 6.1 on monomials. This can be found on page 44 of your math note guides. Now today we're starting a completely new unit, so you can expect some new vocabulary and some new processes for solving problems. So let's go ahead and start by talking about the idea of a monomial. So in basic terms, a monomial is an expression with one single term, okay? Now a monomial, the formal definition is it's a number, a variable, or a product of numbers and variables, or a product of numbers and variables. Okay, so let's talk about some examples of some monomials. So an example of a monomial might be 5 times x, okay? 5x is a product of a number and a variable, making it a monomial. Another example might be 3x squared. So again, this is the product of a number and a variable, even though the variable is raised to an exponent. It's still a monomial. We might have, for example, 9x squared y to the 7th. Now again, this is just a product of numbers and variables, so that makes it a monomial. We aren't adding or subtracting anything, so there's only one term. Another example might be negative 5 halves x y to the 4th. Again, this is just a product of numbers and variables, okay? No addition or subtraction, so it's still a monomial. And the last example might be negative 6 over 11, okay? Because like we said, a monomial can also be just a number or just a variable as well. Now, monomials with the same variables and exponents are like terms. So one of the things that we can do with monomials is if we're adding two monomials together, as long as they have the same variables and same exponents, we can combine them using like terms. So let's go ahead and talk about how to add and subtract monomials. So to add or subtract monomials, what we're going to do is combine like terms. So we need to figure out which terms are essentially on the same team, which terms have the same variable and the same exponent, and all of the numbers, all of the terms that are on the same team, we can add or subtract them from each other depending on what the operations tell us to do. But if they don't have the same variable or the same exponent, we are not allowed to combine them. So make sure we're only combining those like terms. Now, do not change the variables and the exponents when you are adding or subtracting them from each other. So let's go over a couple of examples. Example number 1, the directions say to add or subtract the following monomials. So for number 1, we have 17x minus 25x. Once again, notice how both of these terms have an x attached to them. And so since they both have an x, they are on the same team. So 17 minus 25, that's going to give me negative 8. And again, I'm going to keep that x there because 17x minus 25x gives us negative 8x, all right? So again, we do not change the variables and the exponents. We just change the numerical value. All right, let's go down to example number 7. We have 2/5 CD squared minus 1/3 CD squared. Once again, both of these terms have a CD squared after them. So that means that they are like terms. They are part of the same team. So all we're going to do is we're going to take 2/5 minus 1/3. Now this just requires a little bit of knowledge of fractions. So obviously, in order to subtract these, I need common denominators. So let's go ahead and turn these into common denominators. So a number that 5 and 3 both go into is 15. So I should probably turn these denominators into 15. So 5 times 3 is going to give me 15. And I have to multiply 3 to the top and the bottom. So that's going to be 6 over 15 minus, I want to turn this 3 into a 15. So I'm going to have to multiply the top and the bottom by 5 here. 1 times 5 gives me 5. 3 times 5 gives me 15. I have 6 fifteenths minus 5 fifteenths. That gives me 1 15th. So number 7 is going to be 1 15th. And again, we don't change the variables or the exponents. So it's going to be CD squared at the end. All right. Let's go down to number 11. So number 11, we have 13w squared plus 9w plus 4w squared minus 31w. Now this one's a little bit more involved because we have two different teams. We have a w squared team and we also have a w team, okay? So let's deal with the w squareds first. So I'm going to highlight this some colors. So part of the w squared team is 13w squared and 4w squared. So since those both have a w squared attached to them, we are absolutely allowed to take 13 and positive 4 and add them together. So 13 plus 4 is going to give me 17w squared. Okay, so now let's deal with the W team. So the W team, we have 9w, that's positive 9w, and negative 31w. So what we can do is we can combine these two w's and just form one single term. So 9w minus 31w, well, we need to know what 9 minus 31 is. 9 minus 31 is going to give me negative 22. So we have negative 22w. So this answer is going to be 17w squared minus 22w. Okay, what about if we have to convert words into mathematics? And this is going to be a little bit more tricky and more involved. So let's look at number 13. Find the sum of 16y squared and negative 5y squared. Well, we know that sum means we're adding the two numbers together. So what we're doing is we're taking 16y squared and we're adding it to negative 5y squared. Now we know if we're adding a negative, that really means we're subtracting. So I'm going to go ahead and make this a 16y squared minus a 5y squared. These are both part of the y squared team because they both have a y squared attached to them. So we're just going to combine them. 16 minus 5 gives me 11. So my answer is 11y squared. All right. Going down to number 14, let's find the difference of 10x squared y and 2x squared y. All we're going to do if we're finding the difference of these two, that means we're subtracting. So I have 10x squared y minus 2x squared y. Once again, these are both part of the same team, so I can combine the numbers together. So 10 minus 2 is going to give me 8. So my answer is 8x squared y. All right, let's go ahead and change gears a little bit and move to the next page. So we just learned how to add or subtract monomials. All we have to do is combine like terms. Now we're going to talk about multiplying monomials, and this just gets a little bit more tricky. So to multiply monomials, we're going to have to use a special rule called the product rule. Now what the product rule tells us is if we have two things that are being multiplied together, they have the same base, so let's say our base here is x, and we are raising these two things to some power, okay? What we can do is if they have the same base, we can make this into one single term. So if we had x to the a times x to the b, I could condense this to x to the a plus b. So what this is telling you is something very important. If you're multiplying two terms that are raised to an exponent, they have the same base, or in other words, they have the same number on the bottom of the exponent, then what we can do is we can write it as one single term by simply adding the exponents together. So instead of x to the a times x to the b, I have x to the a plus b. And this just helps me kind of condense my expressions so they're a little bit easier to look at. So let's look at example number 17 and see how this works. So we're going to find the product of each of these examples. We have x squared times x to the third. Once again, these both have the same base. The base of the exponent here is x. So since they have the same base and we're multiplying them together, we can condense this by adding the exponents using the product rule. So instead of x to the 2 times x to the 3, we can condense this to x to the 2 plus 3. We know that 2 plus 3 is 5, so this is actually x to the 5th power. And that's my final answer. Okay, let's look at number 19. We have w to the 7th times w to the 4th. Once again, we have the same base. The base of the exponent here is w. And since I'm multiplying two things with the same base together, I can simply add the exponents together. So I have w to the 7 plus 4, and we know that 7 plus 4 is 11, so this condenses to w to the 11th power. Now, obviously, those are a couple of really basic examples. So what happens if we have things that are more complicated? So for example, what happens if we have something with coefficients? Or what if we have something that has multiple variables, okay? What are we gonna do? Well, again, we just have to make sure that we're being very careful. We can only add the exponents of the bases that are the same. Okay, and also, if we have coefficients, what we're going to do is we're going to multiply the coefficients together, okay? So if we're multiplying two monomials that both have coefficients, we are simply multiplying the coefficients. Then we are simplifying the variables with the product rule. So again, only adding the exponents that have the same base. So let's look at number 20. We have 4x squared times 3x to the 5th. Well, first of all, if we have coefficients, what we're going to do is we're going to multiply the coefficients together. So we have 4 times 3. 4 times 3 is going to give us 12. Then we have x squared times x to the 5th. X squared times x to the 5th, both of those exponents have the same base, so I can add the exponents together. So I have x to the 2 plus 5. 2 plus 5 is going to give me 7, so this comes out to 12 times x to the power of 7. Okay, so multiply the coefficients first, then add the exponents that have the same base. Let's look at number 23. Number 23, we have negative 4a to the third, b to the first, times 3a to the second, b to the fifth. Once again, the first thing we're going to do is multiply the coefficients together. So I have negative 4 times 3. That's going to give me negative 12. Then I have a to the third times a squared. Those exponents have the same base, so that's going to be a to the 3 plus 2, okay? We can add the exponents together because they are the same base. And then we have b to the first times b to the fifth. B to the first times b to the fifth is going to be b to the 1 plus 5. Using the product rule, we can add the exponents together if we have the same base and we are multiplying. So this is going to simplify to negative 12. A to the 3 plus 2 is 5, and b to the 1 plus 5 is 6. So we have negative 12, a to the 5th, b to the 6th. Okay, let's do number 24 because I'm sure everyone's like, what is happening with number 24? 24, we have negative 7, p to the 9th, q to the 3rd, r times negative 4, p squared, q to the 6th, r to the 4th. Once again, the first thing we're going to do is multiply the coefficients. So negative 7 times negative 4. Negative times negative is positive. 7 times 4 is 28. So I have 28. Now let's look at my p values. I have p to the 9th times p squared. Since these are the same base and we're multiplying them together, I can add the exponents. So I have p to the 9 plus 2. Now let's look at my q's. I have q to the 3rd times q to the 6th. Same base, so I can add the exponents. Q to the 3 plus 6. All right, last but not least, let's look at those r's. We have r to the 1st times r to the 4th. So that means I can add the exponents together. R to the 1 plus 4. And this is all going to simplify to 28. 9 plus 2 is going to give me p to the 11th. Then I have q to the 3 plus 6. That's q to the 9th. And then r to the 1 plus 4. That's r to the 5th. So my final answer is 28, p to the 11th, q to the 9th, r to the 5th. Okay, let's look at one where we have to multiply several things together. Let's look at number 29. We have 6m times 7m squared n times n to the 4th. Okay, so we have 3 different monomials being multiplied together. So let's go ahead and take this step by step. First things first, multiply your coefficients. We have 6 and 7 for coefficients. So 6 times 7, that's going to give me 42. Now let's look at our variables. Let's look at m first, okay, because m's the first one I see. So I have m to the first times m to the second times, there's no other m's, that's it. So we have m to the first times m to the second. That's going to be m to the 1 plus 2 because we're just adding the exponents together. Now let's look at our n's. Obviously, first term does not have an n, but the second and third terms do. So we have n to the first times n to the 4th. That's n to the 1 plus 4. And this is going to simplify to 42. M to the 1 plus 2 is m to the 3rd. N to the 1 plus 4 is n to the 5th. So we have 42, m to the 3rd, n to the 5th. Okay. Let's go ahead and do one more example from this section, and then I want to touch on a couple down here in the mixed practice. Let's do one with a fraction. So number 33, we have 12y times 2/3 xy to the 4th. Okay, first things first, let's multiply our coefficients. So 12 times 2/3. Well, we know that 12 is divisible by 3, so I can pull a 3 out of both of these. The bottom is going to turn into 1. 12 divided by 3 is 4. So I really have 4 times 2, which is 8. So my coefficients are going to be 8 here. Now let's deal with our variables. So obviously I have a y to the first and a y to the 4th, but I also have x. I'm just going to write my x first because it's alone. So really we have just no x's over here and 1 x over here. So I'm just having essentially 1 times x to the first, which is just x. Now let's deal with the y's. We have y to the first times y to the fourth. That is y to the 1 plus 4. So my final answer is 8x y to the 5th power. Okay, so let's go over a couple more examples. I'm going to look at number 35. We're going to put kind of all of this together. So 35, 2x to the 5th y squared times 4x y to the 3rd plus x to the 4th times y to the 4th times 3x squared y. Okay, so this looks a whole lot more daunting than it actually is. Let's go ahead and take this step by step. So looking at number 35, let's do the first left-hand side of the equation first. Let's go ahead and multiply these two together. So if I am multiplying 2x to the 5th y squared times 4xy cubed, order of operations says, well, I've got to do multiplication first, so that's why I'm multiplying. So let's go ahead and do my coefficients. 2 times 4, that gives me 8. Then I have x to the 5th times x to the 1st. That's going to be x to the 5 plus 1, or x to the 6th. Then we have y squared times y cubed. That's y to the 2 plus 3. Now let's go ahead and multiply the second one. So the second one, over here, we have a multiplication problem. Again, PEMDAS tells us to multiply first. So we're going to have to multiply these two things before we can add stuff together. So I have x to the 4th times x squared. Obviously, we have a 1 for a coefficient here, right? If we don't see a number, we assume it's 1. And I have a 3 for a coefficient here, so I'm just going to write 3 for the coefficient. And then x to the 4th times x squared, that's going to be x to the 4 plus 2. Y to the 4th times y to the 1st, that's going to be y to the 4 plus 1. Okay, let's simplify this a little bit and then see if we can add. So we're going to have 8x to the 6th. Y to the 2 plus 3 is 5, so y to the 5th, plus 3x to the 4 plus 2. That's going to give me 3x to the 6th, y to the 5th. Oh, would you look at that? So now that I multiplied these and I kind of simplified them, now I see that I have two terms with the same variables and exponents attached to them. So since both of these terms have an x to the 6th, y to the 5th, that means that they are part of the same team, and I can add the numbers together. So 8 plus 3 is going to give me 11, and then I also have to include all of my variables and exponents. So x to the 6th, y to the 5th, and this is my final answer. So if we got a crazy problem that puts it all together, again, we're going to use that order of operations idea. We're going to multiply the stuff together on the left and the right first. Then once we simplify, if they're on the same team, we can add or subtract them from each other depending on what the problem's asking us. Okay, let's do number 38, and that'll be the last example for the lesson. 38 is negative 5cd times negative 3c to the 4th d minus 7c squared d squared 2c to the 3rd. Okay, so once again, please excuse my dear Aunt Sally. We got to multiply the left and the right first. So let's go ahead and do the first side. Negative 5 times negative 3, always take care of those coefficients first. That's going to give me positive 15. Then we have c to the 1st times c to the 4th. That's going to be c to the 1 plus 4, or in other words, c to the 5th. Okay? Then we have d to the 1st times d to the 1st. That's going to be d to the 1 times d to the 1st times d to the 1st. That's going to be d to the 1 plus 1. So that's going to give you d squared. Minus, now let's deal with the second side. We have 7 and 2. 7 times 2 is going to give me 14. Then I have c squared times c cubed. That's going to be c to the 2 plus 3, okay, because we're adding the exponents together, c to the 2 plus 3. That gives me c to the 5th. And then I have d squared, but no d over here, so that's just going to be d squared. Now notice how both of these terms, 15c to the 5th d squared and negative 14c to the 5th d squared, they both have c to the 5th d squared. So that means since they both have the same variables and the same exponents, they are part of the same team, and we can combine them. So since we're subtracting, 15 minus 14 is going to give me 1. So my final answer is 1 c to the 5th d squared, but we can just write c to the 5th d squared. And that's my final answer. So once again, multiply first. Make sure we take care of those coefficients before we start jumping into the variables. And then at the end, if they're part of the same team, you can combine them together. All right, guys, that's lesson 6.1. Make sure you log into Alex and do your homework, and I will see you back here next time. Thank you.